because I don't want you to have to squash your talk at the end. So this is Luke Marsden from Helix ML.
Yep.
He's going to be talking to us about giving every agent its own desktop, lessons from dogfooding Helix ML.
Thank you very much. Cool. Hi everyone. It's nice to be here. Yeah, I'm going to talk about basically how we use agents ourselves and things that we built to do it better. So just to introduce myself, I'm Luke. I self-identify as a kind human. I'm also the CEO at Helix, where we do private agents. And before that, I did an MLOps business. I was SIG cluster lifecycle lead for the Kubernetes project. And I also did a DevOps company doing storage for Docker and Kubernetes back in the early Docker and Kubernetes days. So my thesis is that all information work is eventually going to become about managing agents. And it's just software engineering where that's really started, and it kind of makes sense why it started in software engineering, because that's also where AI came from. But eventually, everyone who is moving information around in any way, basically all white-collar workers, are going to end up having to interact with agents one way or another. It's a bit difficult to see on this slide, but this is from Steve Yeh, who is the creator of Gastown. And he talks about how there are these different stages of AI adoption that people go through. And you go from just kind of using chat completion, like a GitHub Copilot, through to running like a single CLI agent, like a Claude Code. And then you kind of get bored of babysitting a single agent running on your computer. At which point you're like, oh, I should be able to go faster if I run more than one of these in parallel. And that's where the problems start, because the naive approach to that is just run many agents on the same working directory. And then you end up in the horrible situations like when I was rushing to prepare a presentation for a customer in Paris, and I was up early on a Monday morning, and I was trying to get I was trying to run 5 agents in parallel to get everything done. And one of them decided to git stash the work that all the other ones were doing. And then the following day, a different agent decided to rm-rf dot on my Git checkout, and this actually happened. So I've been working since 2023 on making it possible to run agents and LLMs and RAG and all that stuff around it that runs entirely on your own infrastructure. And we've been working with people who care about that. And so kind of late last year, I got really obsessed with this idea of making the snake eat its own tail by actually using our own stuff that we were building to build itself. And so we also were lucky to have customers who wanted to push us towards the sort of coding agent side of the equation. And so we've spent a lot of time thinking about kind of this design space for systems that run agents, and in particular systems that run agents on the server. So all I want to say here is, and we'll go through each of these in turn in the slides, kind of warning contains opinions. And the reason I'm sharing these opinions is that I hope they will be helpful to anyone else who's building systems like this, to kind of both lay out kind of the shape of the landscape and then also carve out some specific opinions, but also why I came to have them. Because you might have different opinions, or you might not have thought about some of these things. So the first big decision, in my opinion, is do you want to carry on letting every developer run whatever agent they like, or maybe the same agent that everyone uses in the company, but on their own specific development environment that's kind of like a snowflake? Or do you want to create a pool of agents that run on your organization's infrastructure that many humans can interact with? And my strong argument is that going for the centralized approach, and I say centralized, it doesn't mean you have to like hand over all your data to OpenAI or run on their infrastructure or anything. You can run it on your own infrastructure still. on Kubernetes or something. But there are some significant benefits from having a centralized approach. For example, you can have a globally distributed team all around the world, and you can say that when the sun sets in Tokyo and rises in London, a different human can carry on doing the work that a certain agent was working on, especially if that agent truly has its own computer for that specific task. And so there's a really nice article written by someone we've been working with, a company called DevCon, and what they said was, to be honest, agents coding is not new. Going from doing it the easier way, which is the way on the left, which is unsafe and per engineer, to something global per company and safe, is what they found interesting in this approach. So that's kind of my argument. My opinion number one is you should give each agent their own computer, not each human. It's almost like you wouldn't hire a team of software developers and ask them all to share one computer. You should give each agent their own computer. The next opinion that I've come to is, do we still need an IDE? Claude Code started making us not look at the code so much, and I genuinely feel like it made me stupider. My opinion is that you should still have an IDE. These agents will increasingly do more autonomous, long-running tasks, but when it comes to actually stepping in and pair programming with an agent, you do still need to be able to look at the code. And having a visual display that follows what the agent is doing is actually really useful when you want to understand what it's doing. Another thing that really matters is that things have to be fast. I got incredibly frustrated with Cursor, back when I was a Cursor user, at just how slow it was at handling keyboard input. And then Claude Code came out with, Anthropic came out with Claude Code, and they've just, and do you know Claude Code is implemented in React? And so they've ended up having to implement basically a web browser in the terminal, and it's just like, can't we just have a working text box? So anyway, the next thing I want to talk about is how you organize your agents. And there's kind of two different schools of thought here. The first one is, do you scale your agents out by number of tasks? Or do you try and build like an organization out of your agents, and you hire a CEO agent, and they hire a VP of engineering agent, and the VP of engineering agent hires some engineers, and you give them all names or something? And we started with the left-hand approach because it's easier, but we're researching the right-hand approach. But so far, what we've found in the research is if you go too fine-grained on giving each agent their own specific role, and you give them these special channels they can communicate on, like agent Slack or something, they end up kind of devolving into enterprise politics. Because they were trained on all of this human data of how humans argue with each other about stupid stuff. So you end up burning a lot of tokens like that. But what I actually think is ultimately going to be appropriate here is to combine the models where you have these coarse-grained different categorizations of roles, like marketing agents and sales agents and engineering agents, because they all need different tools and connectivity to different systems. But within those, you scale the tasks, scale the agents by task. So you have a sort of pool of bees, maybe, and so on. So yeah, I also wanted to share some kind of demos as I go to illustrate the design decisions I'm talking about. So I'll start with this one. So what we've put together here, this is basically this idea of scaling by task. And the notion there is that Kanban is quite a natural fit for scaling by task, because you want to constrain the parallelism. So you can kick off, this is a sample project that's a to-do list app. And what you can see, hopefully, is that by clicking play on the backlog, we've spun up 3 separate computers for those 3 agents that are working on those 3 different tasks. One of them is adding a dark mode toggle, another one of them is fixing a bug, another one is adding like customized categories. And so what you can see here is that we end up down this sort of rabbit hole of like, okay, if you've got, if you want like a good background agent experience that feels like a foreground agent experience, you end up implementing GPU accelerated desktops, because non-GPU accelerated desktops are not very nice to use. But if we're doing AI infrastructure, we've got some GPUs lying around, and it just so happens that the same GPUs you use for inference, a lot of them also support like what GPUs were originally for, which is graphics, and they also support hardware video encoding. So we borrowed a lot of the technology from the gaming industry. I don't know if anyone's ever played like computer games in the cloud. It's actually possible to get pretty low latency and good performance, so we're using the same tech as that. But basically what's happening here from a process perspective is the agent has started up inside the IDE. We use Z because it's fast. And we also forked it so that you can remote control it, so we can inject prompts into the Z agent. The other thing that's nice about Z is that it supports ACP, which means it integrates with all of the major agent harnesses. So it works with Codex and Claude Code. We're not trying to reinvent that wheel. So the next thing is like, well, what's that agent actually going to do when it starts up? And this is a Tessl conference, so it would be bad not to talk about spec-driven development, but I'm actually a huge fan of spec-driven development. So the approach that we've taken is spec is central to what's going on. The human prompt that comes in is something really short, like add dark mode support to my to-do list app or something kind of really trivial. And that prompt goes into this agent. It's actually the same agent, it's just the agent has an explicit planning phase and later an implementation phase. So we prompt the agent to say, please write a plan. Because it turns out that if you get the agent to write a plan before it does the work, you get much better results, because you can then correct it and you can kind of do that design work before the agent has gone off in the wrong direction, when it's harder to steer it if it's in the middle of doing an implementation and it's misunderstood something fundamental. So you put the prompt in, it's the planning phase, and then you have a human in the loop commenting, which you'll see in a second. And then, but the spec is the combination of the human prompt and the planning agent reading the code. So I don't know if you can see this red arrow here. We've got a code checkout for the project, which is whatever repos you've attached. And the job of the planning phase is, based on the user's requirement, write a good spec based on also looking at the code so that you understand what you're going to do in quite a lot more detail than the user specified. And then once you approve the spec, so there's a human in the loop on commenting on the spec, there's also a human in the loop on approving the spec to say, yes, I'm happy with that spec. Then you go into the implementation phase, and because each agent has its own desktop environment, you can now do some interesting things, like the agent can self-QA if it's a web application, and lots of things are web applications. So you can then have the agent put up a PR on GitHub, but then also kind of human in the loop review both the PR, but also the running application in that agent's own computer. And because each agent has its own isolated computer, they're actually Docker and Docker environments, or Docker on Kubernetes environments, they're not treading on each other's toes when they're bringing up a Chrome instance and using Chrome MCP to navigate around. So yeah, I'll show you this spec review phase. So here we had these 3 tasks, or 4 tasks, and like 30 seconds, a minute later, the system's created, each agent has created its own spec. And so if we go and look at the bug where deleting a to-do item from the to-do list doesn't delete it from storage, what you can see is it's come up with this spec. So it was given that simple prompt, there's a bug with deletion, and it's come and written out a much more detailed document. And then you can comment on the document, because I believe that the terminal, like Claude Code, is actually a terrible place for reviewing and commenting on documents. It's much nicer to use a Google Docs style UI, which is why we added one. So you can see there's this kind of wrapper around the agent where you can comment on a line on the document, and it will push changes to the spec. And the specs are all just markdown files in a Git repo. And we put all those markdown files on a special branch that's separate from the rest of the repo. So all the agents can see all the other specs that all the other agents are working on. So they're pretty isolated from each other, but they can all see the history of all the work that's happened or is happening. So then we fast forward this little bit, and what I did was I added a request to, on deletion, let's also do like a fiery CSS animation, so it looks like the to-do list item is burning. And then I can review the rest of the plan. There's basically a to-do list, and then that's the human approval gate. You click Approve Design, and again, we put the prompt in there, and then I sped up the actual implementation part, so I've only got 15 minutes left. But then you can see this is the really cool part. The agent starts QAing the application. I'm not typing here. The agent is typing buy groceries and walk the dog. And then watch, it's going to delete buy groceries, I think. And then we get to see the animation. And I'm like, that wasn't a very good fire animation. So I'm going to prompt it, and I'm going to say, that was a bit rubbish. I want you to make it look like it was actually burning in hell, is I think the phrase I used earlier. So as soon as we, the CSS animation was not cool enough, and then you can press enter twice and it will interrupt the agent that's running in the background. So it does some thinking, it comes up with some better CSS animation, and then you can kind of collaboratively QA what the agent has done directly in the browser. And pretty cool. So it's actually kind of nice to give each agent their own computer, and to have a high quality way of interacting with it that you'd actually want to use. And just to give you a sense of what the board looks like after this, you get to see that you've still got these items to review the spec on, but then you've got this in-progress task over here. So there's a few other things that we learned from kind of the change, the changes that come about when, instead of developers wanting to spend all of their time looking at their IDE to only needing to interact with each agent for a few minutes every hour, of course they can parallelize and try and do more, but they can also go to the gym and do some exercise while their agents are doing work. And so we also wanted to optimize for mobile experience. So we made sure that everything worked on mobile and on tablet. I put a LinkedIn message out that was like, our niche pitch is that this is the best way to run Z on your iPad while you're at the gym. And I had one person commenting that was like, I feel seen. So I guess that's our target audience. But anyway, the other interesting thing about this is that notice this diagram I put up earlier had many users looking at the same screen, or many users looking at the same agent. And so we added this kind of Figma-like ability to have multiple mouse cursors. And so you can actually start collaboratively, multiple humans can basically pair on the same agent's desktop, and they can join in and they can both interact with it. And one of those humans might be at the gym on their iPhone. Anyway, I'll go quickly. The next thing that we found was really important and actually stopped us using it. Remember I was saying we wanted to have the snake eat its own tail. We wanted to dog food this to make it build itself. The next pain point we hit was that it took 40 minutes to build our stack from scratch in Docker. And there's really no point being able to spawn agent sandboxes rapidly if those agents are going to take 40 minutes before they can do any useful work, because they actually want to be able to test and QA the application that they're changing themselves. So we did some quite interesting things with ZFS as a file system to make clones of most development environments are in Docker. That's our kind of working assumption. And Docker in Docker can actually go 16 levels deep, which is crazy. But we don't go 16, but we go like, I think 3. But that means that you can give each agent its own Docker environment, but we also prime the data directory in that Docker environment with the latest version of the startup script running against the latest main commit. So every time an agent starts up, it's got a really fresh, fully cached Docker environment to start up from. And so this is how we use Helix to build Helix. So here we've got an example of a task I added, which was, can you review this external contribution? We had another, like lots of other tasks that are in progress, like we're doing Notion integration for one user. The desktops shut themselves down after an hour of being idle, so I can start this one back up and then interact with it. And I think I speed up the video here, but basically everything we do now is done inside the tool, and so we've achieved that goal of kind of the snake eating its own tail. And most of my day now, when I'm doing technical work, is that I'm reviewing these specs. And I find the 2 lines in the spec where the agent got it wrong, or is making a poor design decision, or is unaware of some other area of the code. And you just comment on those 2 lines, and then it then becomes fairly mechanical for the agent to get each code change all the way through to being close to being ready to merge. So, and then the pull requests that come out of it are quite nice, because we put quite a lot of effort into telling the agent to take screenshots of changes that it's made. So I quite often review pull requests now by just looking at whether I like the change. And that's quite powerful. And you can also we also link automatically to the spec that was used to construct it. Now, I want to talk briefly about token costs, privacy, and Donald Trump. The token costs are exploding. We spend a lot of money now on tokens, which as a bootstrapped startup is kind of painful. But we also have one of these machines. These open weights models like GLM 5.1 and so on can now do pretty much 80% of the work that you need to do. And so if you take, as a meaningfully sized organization, kind of your next 3-month token budget and instead invest in some hardware with like 8x RTX 6K Pros in it, and then you use something, or you build something that allows you to easily switch between different agents and different models, then you can avoid getting locked into like the OpenAI Anthropic ecosystem, but you can still kind of burst out to like Claude Opus 4.8 if you've got something really hard. But for all of the tedious stuff, you should be using local models where you just have to pay for the electricity, in my opinion. Now, the very last thing I'll say is that I'm intrigued by this idea of building a self-improving business. At the bottom layer, you've got a self-improving code base, which is what you can kind of already do here by putting software issues into a Kanban board. If you then plug that into agents that deal with product and support roles, then you can start automatically improving the product based on user feedback. And then if you also add agents that can do sales and marketing and finance and legal things, as well as kind of the founder level stuff of like what's the hypothesis, what's the direction of the market and so on, then all of this is with humans in the loop, but you can start like going a lot faster with fewer people than you could before, which is really interesting. And so the very last thing I'll show you is we also use this to log into LinkedIn, and it's fun because you're collaborating with the agent. And so the agent can be like, oh, can you do two-factor auth, please? Now, LinkedIn thinks I'm a human, and I kind of am. I'm a human that's using an agent kind of like a mechanical suit to do a lot more LinkedIn outreach than I would normally have the patience for. And so I got it to build me a list of 200 people I wanted to reach out to when I was visiting the Bay Area recently. And I actually got a bunch of good meetings. I wouldn't have had the patience to do that by hand. So it's pretty useful. Coming up to time, so just to recap, we've looked at the design space of systems that run agents. I hope that this has provided some useful ideas. We talked about local versus centralized. Obviously, my opinion is that we should go centralized. My opinion is that we still need an IDE. Task scaling seems to be the most appropriate place to start, but I think the org shapes are interesting. Spec-driven development is a must. Make things mobile, multiplayer, get your dev environment set up sorted. Think about how you can reduce token costs, because if it's not hurting now, it's going to be hurting soon. And also think about how you can apply this beyond software engineering. So thank you very much. That's me. If you'd like help doing some of this, then please reach out to me. That's my LinkedIn. Or if you'd just like to compare notes, I'd love to chat. So thank you so much.
Incredible, Luke. Thank you very much. Do we have any questions from anybody? Oh, we've got two. So if our lovely assistant could get the mic and run it down for you. We've got one this side and one this side. Could you just raise your hand again? Oh. Thank you.
Is that working? Yes.
Yeah.
All right. Yeah, that was a really, really cool talk.
Thanks.
And yeah, I think one of the things that I was interested in is the kind of security aspect.
Yeah.
So obviously agents can do lots of things, and you just let it log into your LinkedIn and play around in there.
Yes.
Have you got any guardrails and security things in there, and to what extent have you got it there? Because I find one of the hard things is letting agents run wild versus making them secure, but then having to have lots of input manually.
Yes.
So, yeah.
Well, I think my first argument there is that we're already doing better than OpenClaw on your Mac Mini. When I saw the OpenClaw 1Password extension, I was like, so by just logging it into one website, it's only got one login. It can't go and log into everything else. So that's step one. And then you can also configure on a per project basis what MCP servers you expose. But I think there is definitely a need for, and I think Ivan's working on something interesting in this space, definitely need for tooling that helps you lock down what you're giving permission to and what you're not. It's not something we necessarily want to try and bite off as well. I think we'd rather partner with people who are doing good things in that space. But it's definitely a need. And the more people who ask me for a governance for their agent control plane, I'm like, oh, we need to put a governance panel in our thing. So yes, definitely. Thank you.
I'm just really curious about how also the structure running the GUI games, how's that working?
Yeah, so it's pretty interesting. The way it works is that we run Mutter, which is the GNOME compositor, inside a Docker container, and a Docker in Docker container, and then we use GStreamer plugins to there's this project called Wolf that does this for the gaming community that was written in C++, and for a long time we tried to use that, and then we found it, honestly, I got really bored of trying to write C++, and it was pretty flaky. It ran the whole thing in one process for all of the different containers. So when it crashed, it brought everything down. So we ended up just taking the core pieces of that, which is this Rust plugin for handling NVIDIA CUDA stuff in particular. And this is all on our GitHub if you want to go and have a look. Yeah, also feel free to ping me and I can tell you more about it. Great.
I think we've got one more question.
Okay, one more?
Thanks. That was great.
Thank you.
You talked about still wanting an IDE.
Yes.
Early on. What do you find you want to do with that? I'm assuming that it doesn't need to look like VS Code from 2020.
No.
So can you say a bit about what it does look like?
Yeah, and I mean, we just embedded Z, which is a really nice IDE written in Rust that I like because it's fast. And also when you're running hundreds of these things on a machine, you care about the memory use, the memory footprint more. I really like just being able to watch the agent zip around between different files. And also, I find that watching like a follow of the agent doing the work, just sort of, you ambiently absorb more knowledge about the code base as it's doing that versus the black box that is Claude Code these days. And then when something gets difficult and the agent actually needs help, then you've already got a decent IDE that you can search for things and look around. So my take is you need an IDE on the inside, but you also need the meta IDE, which is like the control plane for all of the different agents you've got running and the higher level view over them. I think we're at time.
You are at time. Thank you
so
very
much.
much.
Cheers.
Please try to give it up for Luke. Please great. So, thank you very much, Luke. If you want to catch Luke, you happy to answer a few questions as well?
Yeah.